Today in this video we're going to be going over percentiles and percentile rank. And first thing I would like you to do is to enter this data into your calculator and run your 1-var stat test and put a picture of your 1-var stat test in this upper right hand corner over here. Take a minute and do so. So here the average of the 20 numbers turn out to be 506.75. And what we need to calculate here are the percentile ranks. The formula we're going to use to calculate the percentile rank is from your video tutorial here. And I just want you to understand that if and when you take statistics in college, there's actually a couple of acceptable different formulas for the percentile rank. Now for us in our class, what we're going to do is we're going to set up a fraction. We're going to take the number of data before the given value. When you see before, that means the number of data less than the given value. And then you're going to add 1/2 times the number of data at the given value, meaning the number of data equal to the given value. And we're going to divide that by the total number of data. So the first thing we really have to do is figure out the number of data less than a given value. So in letter A, it says the percentile rank of 312. Well, we have to find the number of data that are less than 312, so what we need to do is to sort the data in ascending order on your calculator. So I went to my Stat button, chose option 2 for sort in ascending order. And here to find the percentile rank of 312, if you notice, when you highlight 312, the calculator says that you're in, for me I use list 1, and you're in the 6th spot. So since 312 is in the 6th spot, there are 5 numbers before. There are 5 numbers less than or equal to. So I'm going to take the number of data less, which is going to be 5, and I'm going to add 1/2 times. Now I have to take the number of data at the given value, the number of data equal to 312. So basically, how many 312s do you have in your data set? And here there's going to be 1. So I'm going to do 5, the number of data less than 312, plus 1/2 times 1, the number of 312s. And I'm going to divide that by the total number of data, which in this case is 20. Now when I do this fraction on my calculator, and please take a picture of this on your calculator, here you're going to be getting 0.275. And what you're always going to do is you're going to convert to a percentage. So I'm going to move the decimal point 2 places to the left, 27.5. And this is another case in statistics when you always round up. So here when I take 27.5 and I round up to the nearest whole number to get the percentile, here I'm going to get 28. So what does that mean? That means the data value of 312 is in the 28th percentile. It's not 28%, but rather 28th percent. What does that mean? That means that approximately 28% of the data are less than or equal to 312. So that's how you're going to calculate percentile rank. For letter B, let's find the percentile rank of 444 in our data set. So the first thing we want to do is we want to find where 444 is on our list. And here, if you move the cursor on top of 444, your calculator says that 444 is in the 10th spot. So the number of data before the given value, the number of data less than or equal to the given value, since 444 is in the 10th spot, That's going to be 9. So we're going to go 9 plus 1/2 times the number of data at the given value, the number of data equal to the given value, in this case, how many 444s you have, and there's only one of them in the list. And again, we're going to divide that by the total number of data, our n value, which is here 20. Take a minute, calculate that on your calculator, take a picture of it, and include it on this worksheet. And here it looks like you're going to be left with 0.475. So if I was rounding that to a traditional percentage, that would be 47.5%. But here, we're not dealing with percent, we're dealing with percentile. They sound alike, but they have two very, very different statistical definitions. So here we're going to round up to the nearest whole number, and we get 48. So what does that mean? That means the data value 444 is in the 48th percentile. Notice I didn't write 48%. Sounds like it's nitpicking, but it's not. Here the percentile rank of 444 is the 48th percentile. Take a minute, try to find the percentile rank of 586 on your own. Here, 586 is in the 14th spot of your data set, which means the number of data before the given value, the number of data less than or equal to the given value is going to be 13, plus 1/2 times. Now the number of data at the given value, the number of data equal to 586, and once again it looks like there's only one 586 in the list, so we're going to go 13 plus 1/2 times 1, divided by the total number of data, which in this case is 20. So then do on your calculator and take a picture of this. 13 plus 0.5 times 1 over 20. Here we get 0.675. Here we go 2 decimal places, so it would be the unofficial 67.5%. And once again, this is a situation in statistics when you always round up, or 68th percentile. Even if this would have been 0.671. Well, 0.671 is 67.1%. And if you round that to the nearest whole number, you would think it would be the 67th percentile, but no. You always round up. So once you're past the 67th percentile, then we jump up, and now here the answer is the 68th percentile. Remember a few things about percentile rank. Percentile rank is always a number between 0 and 100, but there's no such thing as the 0th percentile, and there's no such thing as the 100th percentile. So the lowest percentile rank you can have is the first. The highest percentile rank you can have is the 99th. You're not allowed to add, subtract, multiply, or divide percentile ranks. They make no sense statistically. And the 25th percentile corresponds to the lower quartile. The 50th percentile is the median. And the 75th percentile is the upper quartile. For letter D, now we're being asked a little different question. We're not asking to find a percentile rank. We want to know in letter D, which of these 20 numbers corresponds to the 42nd percentile? Which of these numbers that if I use that percentile rank formula would give me the 42nd percentile? And to do this, we're going to follow a little different set of procedures. What you're going to do is follow these 4 steps. Step 1, sort the data in ascending order. Well, we already did that for the first 3 parts. Step 2, we're going to use this formula. We're going to take the percentile ranking, which in this case the question says 42, 42nd percentile. We're going to divide that by 100. And then we're going to multiply that by the number of data values in our set, which in this case was 20. So you're going to take the percentile ranking in the question, 42nd, divide it by 100, and then multiply that by 20. Do this calculation on your calculator and take a picture of it. So here, when you do this on your calculator, make sure the 20 is not underneath the fraction of the 100. And here you're going to be left with 8.4. And once again, we're going to be rounding up. You're rounding up to the nearest integer. So here the 8.4 rounds up to 9. Now 9 is not the answer to the question. The question is saying which number in this data set, which of these 20 numbers would correspond to the 42nd percentile. Well, here the 9 is going to tell you. The 9 is going to be the place value. That means the 9th number in your list. We sorted the data in order from smallest to largest. So now go back to your list and find which number is in the 9th spot of your list. So here in the 9th spot, so I use the number that's in parentheses of your list. Here the 9th spot is the number 421. So what does that mean? Which number closest represents the 42nd percentile? The number 421. That means approximately 42% of the numbers in the list are less than or equal to the number 421. So that's how you find the percentile value if you're given the percentile. Take a minute, find the data values that correspond to the 53rd percentile and the 88th percentile. Use the same data list, use that procedure, and find the values that correspond to those two percentile rankings. Take a picture of your calculator when you do the math. So you always take the given percentile rank, which for this first one is 53. You divide it by 100, and then multiply it by n, the number of data values. In this case, you get 10.6. But the key again is you're going to round up to the nearest integer. So you're going to get 11. Even if you would have gotten, let's say, 10.1, normally that rounds to 10, but you're still going to round up to get 11. So is 11 the answer? No. 11 is the place in the order. So in this case, the 11th number in the order corresponds to the value that's in the 53rd percentile. So now you go back to your list and find the 11th data value. And here the 11th data value is the number 520. So 520 would be the data value that's closest to the 53rd percentile. What does that mean? That means about 53% of the data are less than or equal to 520. Take a photo of your calculator's list giving you this answer of 520, and then try to find the data value that's in the 88th percentile. $88 divided by 100 times 20, that gives you 17.6. You're going to round up to the nearest integer, which is 18. So that means the 18th number in your order, in this case, the 18th number in your list, corresponds to the data value of 813. So that means 813 is the data value that's in the 88th percentile. 88% of the data values, approximately, are less than or equal to 813. So now I want you to try a problem on your own. Here you're given some data. It stands for the number of keyboards assembled at this electronics company. Here they gave you a sample for 25 days, so that's your key, that's your N should be 25. And in letter A, they ask you to calculate the values for the 3 quartiles and the interquartile range. So take a moment, enter the data into your calculator, and then take a picture of the 1 var stat test that shows you your 3 quartiles, Q1, Q3, and Q2, which is known as the median, and find the interquartile range. So here are your lower quartile, 41.5. Second quartile, median, 48. Upper quartile, 52. And then your interquartile range, take your Q3 minus Q1, or in this case 52 minus 45.5. So that's going to give you 6.5. So make sure you include these photos from your calculator. Now for letter B, what we want to do is we want to determine the approximate value of the 53rd percentile. We want to find which value corresponds to the 53rd percentile. So we're going to use that formula where we're going to take the percentile rank divided by 100 and then multiply it by the number of numbers, in this case 25. So when you're asked to find a particular value when you're given the percentile rank, that's how you remember this. When you're given the percentile rank, you do the percentile rank over 100 times n, the number of data values. So I want you to calculate this on your calculator and then take a picture of that value. So here we get 13.25. Remember, you always round up when you're dealing with percentile ranks. So here we're rounding up to get 14. So the number that's in the 14th spot of your data, remember you always have to sort your data in ascending order. And then after you sort your data, look in your list for which value is in the 14th spot. So sort your data, and then take a picture of your list and the value that corresponds to the 14th spot, and include that on this worksheet. So here, after I sorted my data, the value that's in the 14th spot is 49. So that's our answer to part B, 49. 49 is the approximate value in the 53rd percentile. What does that mean? That means about, again the key is about. With percentile ranks there's always a degree of inaccuracy, but about 53% of the data is less than or equal to 49. So about 47% is greater than 49 in our data value. Finally, letter C. Now we want to find a particular percentile rank. We want to find the percentile rank of 50. So in order to find the percentile rank, we're going to use the formula. We're going to take the number of data less than the given value. We're going to add 1/2 times the number of data equal to the given value. So the number of, in this case, 50s in our data set. And then we're going to divide that by the total number of data. So what we're going to have to do is we're going to have to go to our list and find where 50 is in the list. So go on your calculator to your list, find 50, and then take a picture of where 50 is in your list and include that on the worksheet. Now here we have something a little bit different than occurred before, in that we have two number 50s. What we're going to do is we're going to highlight the first one because we want to find the number of data less. We want to find the number of data that are less than 50. So since this 50, the first 50, is in the 15th spot, that tells me that the number of data less, 15th spot, tells you that 14 numbers are before that. So here we're going to take the number of data less, which is 14, and we're going to add 1/2 times the number of data equal. Well, here's a good illustration. Here we have two number 50s. So here I'm going to multiply it by 2. And then what we have to do is divide that by the total number of data, which in this case was 25. So the number of data less, 14, because 50 is in the 15th spot. There were two number 50s, so we're going to do 1/2 times 2, the number of data equal, and then divide by the total number of data. So do this quotient on your calculator and include a picture on the worksheet. Now here when you do this on your calculator, you get 0.6. Well, we have to round up to the nearest percentile rank. Here 0.6 would be 60% if we're dealing with traditional statistics, but we're not. We're dealing with percentile rank. Here, since you're exactly at this 0.6 value, that tells you that your answer is the 60th percentile. When your math gives you an exact percentage, then that's what your percentile rank is. So here, 50 is in the 60th percentile. If you would have done this division and you would have gotten anything bigger than 0.6, let's say you would have gotten 0.600001, that would be 60.001%. That would have made it in the 61st percentile. You would have then surpassed the 60th and been in the 61st. But here you got 0.6 exactly, so that means 50 is in the 60th percentile. Problem number 2, the following data gives the number of runners left on base by each of the 30 Major League ball clubs. So here they're telling you that n, the number of numbers, is going to be 30. And you have to calculate the values for the 3 quartiles in the interquartile range, find the approximate value for the 63rd percentile, and then find the percentile rank of 10. So take a minute or two, enter all 30 numbers into your calculator, and then take a picture of the 1 var stat test that determines the 3 quartiles, Q1, the median, which is Q2, and Q3. Take a moment, enter the data into your calculator, and then take that picture and supply it on the worksheet. So here there are 30 numbers. The average is a little over 7.3. The first quartile is 5. The second quartile, Q2, 6.5. The third quartile, the upper quartile, 8. And here your IQ, Q3 minus Q1, 8 minus 5, or 3. Now what we have to do is we have to find, in letter B, the approximate value for the 63rd percentile. Anytime you are given a percentile rank, you're going to be using the formula that says take the percentile rank, which in this case is 63, divide it by 100 to turn it into an approximate percentage, and then multiply that by the number of numbers, which in this case is 30. So here on your calculator, you're going to do 63 divided by 100, multiply that by 30, take a picture of that result, and add that to the worksheet. So here, 63 divided by 100 times 30 gives you 18.9. What you always do is you always round that up. So in this case, that's going to give you 19. That means the 19th number in the list corresponds to the 63rd percentile. So what you need to do is to sort the data in order and then go in your list to where the 19th number is. Remember, the way you sort data is you press Stat and option 2, sort in ascending order. So I want you to take a picture of the list of your calculator and have the cursor in the 19th spot. So here, the 19th spot corresponds to 8. So that means we say 8 is in the 63rd percentile. What does that mean? That means approximately 63% of the data are less than or equal to 8. That's the key. For percentile rank, you want to understand the mathematical symbol less than or equal to. And it's an approximate value. It's not an exact value. When you get your percentile rankings for your SATs and your PSATs, they give you your percentile rankings, but again, these are approximates because there's lots of students all across the country that have the same grades as you, the same exact score on the PSAT as you. So percentile ranks are approximations. For letter C, problem C, now we have to find the percentile rank of 10. So in order to find a particular percentile rank, we're going to use the formula. You take the number of data less, and then we're going to add 1/2 times the number of data equal, and then we're going to divide that by the total number of data. So what we need to do now is go to our list on our calculator, and we have to find 10. So I want you to go into your list of your calculator and take a picture of 10 in the list. Be sure to include that picture on the worksheet that you're working on. Here there are 2 10s in the list, so here we're going to highlight the first 10 because the number of data less. Well, the first 10 is in the 26th spot, so that means there has to be 25 data values before that 10. So the number of data less is 25, plus 1/2 times the number of data equal, so the number of 10s. Here there are 2 10s. And then we're going to divide that by our n value, the total number of data, which in this case they told you there were 30 ball clubs. So here our total number of data is 30. So here to calculate the percentile rank of 10, you're going to do on your calculator, 25 plus 1/2 times 2 over 30. Please include a picture of this work on your calculator. And here you should have gotten 0.8666. We convert that to a quote-unquote normal percentage, 86.67%, but remember, you always have to round up. So in this case, that's going to give you 87. So we say that that's our answer. 10 is in the 87th percentile. What does that mean? Well, since 10 is in the 87th percentile, that means that approximately 87% of teams had a value that's less than or equal to 10.